So of course, as with most things in chapters 5 and 6, once we learn the definition of something, it's time to figure out the probabilities that go with it. Now there is actually a function in the background. There's a formula that figures out probabilities. But I'm not going to show you the formula because it involves mathematics that we don't use, particularly combinations, which we don't cover. But suffice to say that there is a magical formula that lets your calculator and/or StatCrunch figure out these probabilities for us, which is great. Now, don't forget the definitions. N is always the fixed number of trials. P is the probability of success. And then A and B are the number of successes that are required for the specific problem that you're looking at. This table is in your exam notes packet, so it's not a question of memorizing it. It's a question of knowing how to utilize it appropriately. All right, so let's do so. All right, so we have determined the indicated probability for a binomial experiment with the given number of trials, n, and the given probability of success, p. Sure, fine, lovely. Okay, so you'll notice here that that's a given number. We have a number that's given to us, namely 2. So we want to find the probability of 2 successes. So I'll just note that we're finding the probability that x equals 2. This is the given number issue. A lot of times I won't bother saying x equals 2, but I mean that. Okay, so we just go to StatCrunch. So if it's x equals 2, we're going to use the equals in StatCrunch. Now StatCrunch, to do StatCrunch, the path is right here. So notice that StatCrunch path. Make a note of it. And again, it's on the yellow sheet, but just so you have it, StatCrunch path is right there. And we'll talk about the between and standard options when we get there. All right, so let me go to StatCrunch. I'm just going to open a blank StatCrunch sheet. And I'm going to go to Calculators, Binomial. So Stat, Calculators, Binomial. And here's the binomial calculator. So I'm going to tell it how many trials I have, which was 15. I'm going to tell it my probability of success, which was 1/4, 1 divided by 4. And I'm going to change this to an equal sign. So I click on that little menu and there's options. And because we want the probability that x equals 2, I can type in the 2 and say compute. And there it is. It even lit it up in red for me. It's 0.1559. And it's as simple as that. 0.1559. And when you think about it, this thing is really doing a lot of very powerful work for us. It shows us the lit up value. We just told it the n. I could even tell it as a fraction, 1/4, and it figured it out. Very nice. All right, the next one has n equal to 85, p equal to 0.03, and I want the probability that it's less than 4. And if you look at it on the page, it says x less than 4. That little pointy end is facing towards the x. So you just change this symbol to match that. That's a less than symbol. Currently it's doing less than 2, so I want to change that to a 4 and say compute, and there it is. Now so far everything we've done is standard. I'll show you the between a little bit later, but standard means you're basically going one direction. So these symbols are all standard. So it's 0.7483. So I'll go write that on the page. The probability that x is less than 4 is 0.7. I've already forgotten it. 7483, I think it was. 7483. Yep. And you're done. All right, now what about the probability that x is greater than or equal to 11? Now notice it has that extra little bar into it. So that means it's 11 or higher. Right? This one up here with the 4 didn't have that. So that was strictly less than 4. But this one's a greater than or equal to. Okay, so I've got to put in my n, which was 16, my probability of success, which is 0.78. I'm going to change this symbol to a greater than or equal to. I'm going to change this number to 11 and compute. And you can see it's the red bars that are lit up. Those red bars, when you add them all up, make 0.8812. Done. All right, these three were all standard. So you could make a little note to yourself. Standard, standard, standard. They're all standard. The only ones that are between are, amazingly enough, the between ones, right? So it looks like this. When you have 2 is less than or equal to x, which is less than or equal to 5, when that happens, that's a between. All right, how does that work? Well, you click between, you tell it the n, which is 8, and the probability of success, which is 0.28, and you type in your values. So I want the probability that 2 is less than or equal to x, which is less than or equal to 5. If you look in that parentheses, it's the symbols that we see on the paper. And then you say compute. And you're done. Okay, so I'm actually going to show these as well in the calculator. So if you're not working with a TI calculator, you can skip ahead to the next video. All right, TI-84 folks, let me get you my TI-84. All right, so for the TI-84, you have to go to the distribution menu, which is above your VARS button. So you hit second distribution, or second VARS, and you're looking for the binomial PDF for the first problem. So there's 2 functions that we're going to have to work with, and binomial PDF is the one that gets used for a given number. So we'll grab that. Then we tell it the number of trials, which for letter A was 15. The probability was 1 divided by 4. You can enter a fraction as well. And then 2 was our x value. And I go to paste, and I press enter on paste, and then I press enter again, and I get the same value. So if you're on a TI-84, we'll just make a little note here, TI-84, you write binom PDF 15, 1/4, 2. And that gets you that value. Lovely. All right, and so I'm following this. It's binom PDF, it's the first one. The next one is a less than. So if I look, it's binomcdf NPA-1. Okay, so if I'm on the TI-84, it's going to be binomcdf. N was 85, P is 0.03, and then 4 take away 1, which is 3. All right, so let me go back. So second distribution, binomcdf, which is closer to the bottom. If I go up, I'll get around. So binomcdf, 85, 0.03, and then 4 take away 1. Paste, enter. And there you have it. Okay, third one. Well, that's a greater than or equal to. A greater than or equal to is 1 minus binomcdf NPA-1. So that's pretty complicated. Okay, so on the TI-84, oops, I'm going to write it. It's 1 take away binomcdf 16.78 11 take away 1. And we can find this in pieces. So we can say, hey, find me binomcdf. There it is. So I can change this to 16.78 11 take away 1. Paste. And then I want 1 minus that value. Now technically you can type it all at once. You can type 1 take away, then go grab the binomcdf. That's why you're pasting. Oh, I pressed the wrong thing. Second distribution. There it is. Binomcdf. Oh, here it didn't like me. 1 minus. Second distribution, binomcdf. And there it is. Put all those values in, paste. That's why we're pasting, because then it puts it all in one line. And there you have it. So it was 1 minus 0.3048. Did I type something wrong? Oh, I did. It was 0.78. Rats. Here, hold on, let me go grab this. My probability of success was off. Let go in here. Second insert 8. There we go. That's the right answer. So then 1 minus that, that's the correct answer. So then 1 minus binomcdf. There it is. There you can see it. Oh, so it's 0.1188. So if you write that down, it could be like this. 1 minus 0.1188 was 0.8812. So you can do it in two pieces, or you can do it all at once, either way. Now the hardest type is actually the between type. So you have to take binomcdf NBP, which is the high value, minus binomcdf NP, but then the lower value loses 1. You don't really need to know why, it works. So, I mean, I can explain why. If you ever really want to know, you can let me know. I'll write you an email. So binomcdf. So what you're doing is you want to include the 5. So it's 8, comma 0.28, comma 5. So you want to include that 5, and then you want to cut it off. So I'll explain right now. So you want to cut it off. You want to keep the 2. So if I put 8.282, it'll be wrong because I'll be getting rid of the 2. And I want it between 2 and 5. If I do this, it'll be 3 and 5. Right? 3, 4, and 5 will be included. So I want to subtract 1 so that way I'm taking away 1 and 0. So this will work. Right? It just takes some doing. So let me go grab the calculator. So second distribution, binomcdf, and then I tell it 8, I'll try to remember this, type this correctly this time, 0.285, paste, take away, go grab again, second distribution, binomcdf, 8.282, take away 1. Paste, and you can just type 1, you don't have to do the subtraction that way. And there you have it. It's the same answer, it's just a bit more of a pain.